Alright, welcome to lesson 2-9 video 2, and we are going to look at area and perimeter in the coordinate plane. So let's look at example number 1 here. This says find the perimeter and area of math, so it's labeling each of these points as M-A-T-H. And well, first thing we'll do is we'll label those. So this first point, negative 3, 3 is here. So this is going to be M. The second point, 5, 3 is here. That'll be A. The third point, 5, negative 4 is here. That'll be T. And then lastly, we have H, which is right here. So it wants us to find the area and the perimeter. Now for the perimeter, all we need to do is have all 4 side lengths and then add them up. So let's calculate what each of those are by counting. So I'll start with T here and I'll count up. We have 1, 2, 3, 4, 5, 6, 7 units, which means the other side as well is going to be 7 if I count up. That's 7 as well. And then from M to A, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, which means that this will also be 8. And you can confirm that by counting 2, 3, 4, 5, 6, 7, 8. So in order to get the perimeter of this, I would need to add 8 plus 8 plus 7 plus 7. Okay, and so you can do this math real quick. This will give us 16 plus 14, and 16 plus 14 is 30. Now, for these, we don't specify what the units are, and anytime we don't specify the units, you can just put, what I've told my students in the past is you can put U. I'm just going to put units, because I know that that's 30 total units. That's the distance around this rectangle. All right, let's change colors here for area. So for area, I only need 2 dimensions. I need length times width, and you could call this length and this length as long as you have something in the y-axis and the x-axis. So for area here, all I need to do is remember to multiply length times width. So I will just need to multiply 8 times 7. And that's going to give us a total of 56 units squared. And if at any point you need to, you can plug these in your calculator if you wanted to just double check 8 plus 8 plus 7 plus 7. That's a good practice to solve it and then check it. So that's 30. And I did the perimeter there. And then 8 times 7, hopefully we know our multiplication tables. And that gives us 56. Okay, so we'll label this here. So this was our area. And up here was our perimeter. Okay, let's do another example. So this one says find the perimeter and area, again, of this triangle with these points. Okay, so these are the vertices here. Negative 7, negative 4 is going to be right here. Negative 7, negative 4. This is going to be, well, this one's going to be negative 6, 5. And this one will be 5, negative 4. Okay, so to find the perimeter, I will need to know the distance around this entire triangle. Now, there's one of these sides which is easy to calculate, which is this side here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this distance is 12. But you'll see that I run into a problem with these two sides, right? Because they're not nice. They're not either vertical or horizontal. So I'm going to have to either use the distance formula or the Pythagorean theorem. Now I am partial to just using the Pythagorean theorem because what that means I can do is I can draw a couple of smaller triangles here. So I just use my mind's eye to draw this other triangle here, and now I have a right angle here. And if I have a right angle, then I can actually use the Pythagorean theorem. So before drawing this triangle, you cannot use the Pythagorean theorem on this triangle here because there's no right angles. Okay, but here, if I were to draw this triangle in here, I can use the Pythagorean theorem to get this length here of this hypotenuse. So let's count to find this length and this length. So this little itty bitty length here is a 1, and I'm just drawing that in there. It's kind of hard to see there, but that's a 1. And then this length is 1, 2, 3, 4, 5, 6, 7, 8. Let me make sure that was right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm glad I checked. So that's 9. It was a little bit off there the first time. Okay, so in order to find this length here, I can use 9 squared plus 1 squared is equal to c squared. And 9 times 9 will be 81. 1 times 1 is 1. So 82 is equal to c squared. And to get c by itself, I would just need to take the square root of both sides. So if I pull my calculator out, I can do second root of 82, and that just gives me the square root of 82. Okay, so I'm going to say that c is equal to the square root of 82. Okay, so that's this side length here, so I'm going to put this right here, the square root of 82. Now, I'm going to convert it to a decimal later, but I'm not going to convert it to a decimal yet. You'll see why in a second. Basically, it has to do with rounding. So let me change colors yet again here, and we'll change to purple for this next one. So let's calculate this length, and in order to calculate this length, I can draw myself another triangle here. And it looks like this is going to have a height of 1, 2, 3, 4, 5, 6, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like this one over here. And then this length here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can do another Pythagorean theorem problem because this is my right angle here. And I can find this length here. So I can set this up as 11 squared plus 9 squared is equal to c squared. And I'm going to do a little shortcut here. I can see that I have c squared here, so if I want to get c by itself, I can go ahead and take the square root of both sides. So all I really need to do here is plug the square root of 11 squared plus 9 squared in our calculator. And this should look a whole lot like the distance formula, except without the x1 minus x2 or y1 minus y2. We're just using the distances there. So let's do second square root, and then we'll do 11 squared plus 9 squared, and that gives us the square root of 202. So this length here is the square root of 202. Okay, so the entire perimeter is going to be this length plus this length plus this length. So that will be 12 plus the square root of 82 plus the square root of 202. Now, this is not very practical though, right? So this is where we can get out our calculator and plug this in and get a decimal answer. So 12 plus the root of 82 plus the root of 202. And the reason I say this is not practical is because what is that value? Just by looking at it, it's kind of hard to tell and estimate what the actual decimal value is. So let's calculate it for us, have the calculator calculate it for us, and that's about approximately 35.27. So I'll round to 2 decimals here. So 35, let's see what it was again, 35.27, and that's just units, not units squared, units, because that's the distance around the triangle. Okay, so that is how you would calculate perimeter. Okay, so take a second and write this down, because this is going to go away, because I'm going to need all the other white space on here to do my calculations for area. Okay, so if you need to, pause the video, because I'm about to clear this out. Okay, so now we already calculated perimeter. Now to calculate area, I need to do 1/2 the base times the height for the area of a triangle here. So the base is easy to find. That's this right here. That's the base. Okay, but when I am finding base and height, remember my height needs to be perpendicular to whatever the base is. So the height is not this diagonal length or this diagonal length. It's, if I were to drop a string from the top here, it would fall straight down to the bottom. So the height is actually this distance. So the height is 1, 2, 3, 4. Hold on, let me count that again. I'm having trouble seeing this here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the height is 9. And the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's the total distance there. Okay, so using my formula, that's going to be 1/2 times the base 12 times the height 9. And at that point, we can get out our calculator and do 1/2 times 12 times 9. And that is equal to 54 units squared. Because remember, we're talking about area. So what does that mean in the context of this problem? That means that the total number of boxes that are this size that I'm coloring in right here, there's a total of 54 of those that can fit in this triangle right here. Now you'll notice, now they're not going to be perfect whenever I fit them in there, because you'll see that some of these boxes are being cut off. Like this is not a full box right here. This is not a full box right here. But if I were to total all of them up and put them all back together like puzzle pieces, there would be a total number of 54 of those boxes that would make up the area of this triangle right here. In other words, if I were to take a paintbrush and paint that entire triangle, it would take 54 units squared of paint to cover that entire triangle. All right, make sure you try those U-tries, and I will see you in the next video.